Welcome to This Explainer. We're right on the edge of a technological shift that is just quietly developing in the shadows right now. It's an emerging field that, quite frankly, makes today's artificial intelligence look, well, kind of simple by comparison. We're talking about the quantum revolution, its super rapid timeline, its monumental hurdles, and the very immediate threat it poses to our global infrastructure.
We constantly hear these breathless predictions about AI being humanity's biggest existential threat. You see the headlines absolutely everywhere, like Elon Musk predicting human-level AI by 2029. We're always being warned about rogue algorithms and automated decisions taking over. But what if we're all actually looking in the completely wrong direction?
So let's really explore this. What if there's something even more powerful, like a literally world-breaking technology fast approaching? Today, intelligence agencies, global banks, and top cybersecurity experts aren't just losing sleep over chatbots anymore. They're actually panicking over quantum computing. So we're going to unpack exactly why that is and what they're desperately trying to do to stop it.
To really grasp the danger here, we first have to understand the mechanics behind it. It's so crucial to realize that a quantum computer isn't just a faster version of the laptop sitting on your desk. It doesn't just run the same old code at a higher speed. No, it operates on completely different laws of physics, specifically quantum mechanics, using these truly mind-bending phenomena like superposition and entanglement.
The best way to visualize this difference is actually through a simple maze. A classical computer, well, it operates kind of like a blindfolded runner. It races down every single dead end, one at a time, sequentially trying every single option until it finally finds the exit. But a quantum computer, it takes a bird's-eye view of the whole thing. It uses its unique physics to assess all probabilities simultaneously. It instantly sees the correct path, no matter how impossibly complex that maze becomes.
And because of this massive, truly exponential advantage, these machines could bring some absolute miracles to society. We're talking about solving impossibly complex problems in mere minutes, problems that would literally take today's greatest supercomputers millions of years to crack. They could map out cures for diseases, perfectly forecast climate shifts, and totally optimize our global supply chains basically overnight. The potential is just staggering.
But that brings us to a really crucial, kind of unsettling question. If this technology is still largely experimental, if we don't have powerful quantum computers just sitting on our desks today, why on earth are the world's most powerful governments scrambling to prepare for it right now? Why this sudden intense urgency? Well, the answer is a frankly terrifying cybersecurity strategy known as harvest now, decrypt later. Right at this very moment, malicious actors and adversary nations are scraping and stealing massive troves of encrypted data. Now, they can't actually read it yet, but they're patiently hoarding all these sensitive government files, military secrets, and financial records, just waiting for the day they finally possess a quantum key to unlock the whole shebang.
And the core of this threat revolves around something called Shor's algorithm. This is a mathematical approach that basically allows quantum computers to efficiently shatter the public key encryption, things like RSA and elliptic curves, that currently protect our entire digital world. Just to put that into perspective for you, this is the exact same encryption protecting our $173 trillion daily global financial infrastructure. If that encryption breaks, the trust in our whole modern economy basically collapses right along with it.
And guys, the clock is seriously ticking. The expert consensus right now, and this includes estimates from the U.S. Department of Homeland Security, suggests that by 2030, give or take 2 years, a rugged quantum computer capable of breaking today's ciphers could actually be a reality. Now, sure, some estimates do push that out a bit further, but the sheer mathematical certainty that it will happen is exactly what's driving this current panic.
But hold on, there is a massive catch here, and it's the hardware itself. To actually hit that 2030 timeline, engineers have to build incredibly intricate machines. Scaling them up requires overcoming a huge obstacle called decoherence. You see, these quantum bits or qubits are exquisitely fragile. The absolute slightest thermal noise, an imperfect gate, or even just a microscopic material defect instantly destroys the delicate quantum state, which completely ruins the entire calculation.
So it's really vital that we balance all this breathless hype with some grounded engineering realities. As top researchers are quick to point out, the narrative swings pretty wildly between extraordinary optimism and deep, sober technical skepticism. The theoretical math is definitely proven, for sure, but the physical limits of building, say, a million-qubit system that doesn't just instantly collapse under its own environmental noise, that's a massive hurdle we just haven't fully cleared yet.
In fact, a lot of leading researchers compare this struggle to the endless, decades-long delays we saw with the nuclear fusion project.
Just as plasma instability constantly undermined the elegant theory of fusion, keeping it supposedly just 20 years away for a half-century, quantum decoherence directly threatens the long-term stability we need for reliable quantum computation. The theory is absolutely perfect, but the physical implementation is turning out to be incredibly stubborn.
So, the ultimate dilemma we're facing is this. Knowing the world-breaking risks to our encryption and facing a timeline that could range anywhere from a few years to a few decades, how exactly do we actively defend a $173 trillion financial system against a phantom threat that hasn't even fully arrived yet?
Well, the security community's answer is post-quantum cryptography, or PQC. This represents an urgent, massive global shift toward entirely new mathematical defenses. Unlike our current encryption, PQC relies on insanely complex math, like lattice problems, for example, that are computationally impossible for both classical supercomputers and future quantum computers to crack. It's basically fighting math with even harder math. And this isn't just some academic theory, it's a highly active roadmap. In August 2024, NIST officially finalized the primary PQC standards. So now institutions are racing through a phased migration. Between now and 2028, it's essentially a massive game of hide-and-seek, trying to find exactly where all the old encryption lives inside their systems. Then, prioritized migration officially kicks in, driving toward a hard regulatory deadline to ensure fully quantum-safe operations by the year 2035.
And let me tell you, the financial sector is taking this incredibly seriously. Large banks with massive budgets are targeting a super aggressive 80% PQC adoption rate by as early as 2026. They definitely aren't treating this as some distant, theoretical exercise. To them, this is an immediate, critical operational mandate. They have to lock down their assets against those harvest now, decrypt later attacks we talked about.
To survive this monumental shift, organizations are practically scrambling to execute 3 vital steps. First, they're taking a massive inventory of all their digital locks. Second, they're prioritizing the data that has the longest required lifespan, mainly because that is the absolute primary target for harvesting. And third, they are engineering crypto agility, which is the architectural flexibility to just seamlessly swap out old algorithms for new ones as the quantum landscape inevitably shifts around them.
But, beyond just upgrading digital locks and securing banks, this technology introduces a really profound ethical hurdle. If we actually achieve stable quantum computing, how on earth do we govern this world-altering resource? We really have to design mechanisms that balance scientific excellence with global equity, making sure we don't drastically exacerbate the technological divide that already exists.
Because the ethical dilemmas here are truly staggering. We're facing a potential quantum divide where only a handful of wealthy nations or corporations hold the keys to all this incredible power. There's also this severe risk of eroding personal privacy through totally unchecked mass surveillance if all our encryption is suddenly broken. And, of course, there's the very cold, neutral reality of superpowers racing to militarize these quantum discoveries for their own game.
Without robust international frameworks in place, something similar to the nuclear non-proliferation agreements, the sheer opacity and raw power of quantum tech could easily mirror the worst regulatory failures we've already witnessed with artificial intelligence. We absolutely cannot afford to unleash algorithmic biases or compromise global security simply because we were just too slow to draw the boundaries.
Ultimately, as we sit right on the cusp of this massive transformation, we are left to wonder, how will society fairly distribute access to a machine that can simultaneously map the cure for a disease and totally dismantle the security of the modern world? It's a huge question we must answer today, before the quantum future simply becomes our present reality. Thanks so much for joining this explainer, and keep questioning the technologies shaping our world.